Is it just the two of you, or are we waiting for Jetta as well?
What was that?
Is it just the two of you, or are you waiting? We're waiting for Jetta as well.
It's just the two of us. Jetta couldn't make this time today, so it's just the two of
Okay,
us.
sounds good. All right.
So first question. So on our little Excel spreadsheet, it said that you were part of your like accomplishments was like atmospheric dynamics. So we were wondering like what inspired you to get into atmospheric dynamics?
Um, yeah, nothing actually really inspired me. I I started out interested in astronomy and studying like stars and supernovas and stuff like that. I ended up doing atmospheric dynamics sort of by accident. I liked astronomy, but I kind of felt like the time scale of learning about whether you were right about or something or wrong was a long time, and I started getting interested in planetary science instead. And
Mm-hmm.
then, but I also went and got an engineering degree in aerospace engineering. I worked for the Jet Propulsion Laboratory for a couple of years. While I was there, I met a couple of professors from Caltech. So when it became time, I decided I wanted to go get my PhD, and I went to talk to them about applying. They encouraged me to apply there. So I applied there, I got in, and the professors I knew happened to be atmospheric science professors. And so
Oh,
since I knew them, I liked working with them. That's how I got into it. So,
nice.
so
Nice.
a little bit by accident.
Yeah. So what does your like day-to-day work like look like with this field?
It's all over the place. Okay, so because I'm both a scientist and an engineer, I do two types of work. I model the atmosphere. I work with dynamical models to try to simulate how the atmosphere works. So when I'm doing modeling, there's sort of like two flavors of tasks that I spend my day in, which is I'm logged into my computer. I'm either coding up some new feature to the model, or I'm trying to run simulations on the supercomputer, download them, analyze them, and figure out what's going on. There are like standard ways of analyzing the results to try to understand like what's the climate doing, why is the wind moving this way. So that's on my sort of science days. On my engineering days, today's one of those. I spend my time in the lab working on developing new instruments, and I spend a lot of time running around because I'm leading the development of instruments. So I have a team of engineers working for me. So I'm the one stuck like we're missing this part. I got to run around, order parts, get on the phone, take care of this stuff. Right now, today, I'm dealing with the fact that the 3D printer is jammed. I got to go fix that. Or, so mundane stuff, plus when everything's working, we'll be in the lab and we'll run our experiments. So, for example, I have some experiments where we're trying to create, we want to fly on microgravity flights where you do like sometimes called a vomit comet, where you do these parabola flights where you go way up high and then you dive. And when you're diving, you get like the feeling of low gravity. And we want to do these experiments where we'll have like a bed of sand and shoot basically metal balls into it and look at the ejecta to simulate what's happening on the surface of an asteroid. And so we have a vacuum chamber that's we're going to fly eventually, but we're testing it in the lab right now. So today is run around, try to get everything working. Hopefully by Wednesday, we'll just sit and take lots of data and try
Mhm.
to figure out if the experiment's working right or not. So my days vary. And
Yeah.
then there's a third type of day when you're the type of scientist I am, which is I'm not a professor somewhere. I work for an institute, which means I have to write proposals to win funding to pay for my salary. So the third type of day I have are the days when I have to sit around and write proposals,
Okay.
which can be fun, but they also can be just as tedious as it sounds. Because
Yeah.
the first 20 minutes of writing a fun idea down is fun. The next 2 hours of writing it so it's intelligible to somebody else is boring as hell. So
Yeah. Yeah. So you would say like because you're an engineer like and a scientist, like you measure and collect the data, but you also like create tools to measure and collect the data?
yes,
Oh, okay.
yeah.
That's cool. All right. Where am I? Where am I? What are some of like these like instruments? Like
Well,
or is
so
it like these huge names that like we won't even be able to understand?
well, no, they're not that bad. So you just have to learn to decode it, right? It's like learning a foreign language. Like the main type of instrument I'm developing is called a laser Doppler magnetograph. Not magnetograph. I haven't done a magnetograph in 20 years. A laser Doppler anemometer. So laser is pretty obvious. It uses lasers. Doppler just means we're taking advantage of I'm using lasers to shoot the laser beams at particles in the air. As the particles move, the light scattered off that laser beam is shifted and has a Doppler shift. So if you've ever seen that in the physics class, that's all it is. An anemometer is just a fancy Greek word for wind measurement. So it's a way of measuring the wind by measuring the particles floating in the wind. And so we want to use that at Mars. We want to use that at Titan because we don't have a lot of wind measurements, and this would be a great way to try to get some wind measurements. So that's the primary technique I work on most of the time.
Okay. Cool. Tucker, do you have anything to add on to before I switch a little subjects a little bit?
Well, I was gonna go on with how you were talking about Titan, and I was gonna ask about what makes Titan like a moon set of another planet, and why is it a moon of Saturn rather than its own planet, basically.
Oh, this gets into like what is a planet, what's not a planet. If Titan was floating in space on its own, it's big enough we would consider it a planet for sure. It just happened that it formed around Saturn, and since it's rotating around Saturn, we call it a moon or a satellite. This is why some people in my field hate debating what a planet is or isn't, because at some point it doesn't really matter. What does matter is Titan is cool as hell, because Titan has more natural gas on its surface than we have in all of Earth, right? It's basically, instead of water, and then you get like lakes of water and rain on Earth, you have lakes and rain fall of natural gas, basically. So the same natural gas that sometimes drives, tractors and stuff like that is sitting on the surface of Titan, but it evaporates, makes clouds, and then rains back out. So it has this whole cycle. So it looks, if you looked at it, it sort of looks like Earth. You see like, streams and riverbeds, you see clouds and storms and everything else, but it's all natural gas. And it's at like 90 Kelvin. What is that? Well, it's a few hundred degrees below zero. Let's just put it that way. I don't convert to Fahrenheit easily. It's really, really cold, and yet it looks a lot like Earth. That's why it's awesome. And whether it's a planet, a satellite, or I don't care, right? So, yeah, I don't know if that's really answering your question. It's part rant on my part, so it's probably more than you wanted.
I think it answers it well.
Have
And
they
so
thought
like
about-
those like
Oh, go ahead, Tucker. Sorry.
so like those natural gases are like what makes up that like hazy atmosphere that it has.
Right. So natural gas is methane. So part of that haze is methane. Part of it is ethanol. There's benzene. It's basically like all the crap that's in your car engine, all that nasty stuff that you get on your hands when you change the oil or whatever. That's what the haze on Titan is made up of. Yeah. So
Okay.
you wouldn't want to breathe it in. Poisonous.
All right.
Have they thought about harvesting it and bringing it back here to Earth?
A few people have. Right now, everybody thinks water is more useful, so that's what they focus on, liquid water. Also, since water is useful because you can both use it as a propellant and you can drink it, and it looks like there's water on the moon, and there's definitely water in asteroids, and those are all easier to get to. People don't spend too much time thinking about getting natural gas back from Titan.
Okay.
Right now, it's just really, really expensive.
Yeah.
So, but 100 years from now, who knows, right? So.
All right. And since we're on the topic of planets, so what's like an exoplanet? That's something I've heard it since I was like in middle school. I just never have really understood like what the difference between exo and planet is.
This is where sometimes we get messed up because of old the way they used to do things in the old days, right? Like 200 years ago, if you went to college, you learned Greek and Latin, and so they loved using Greek and Latin words to stick together, right? Exo is just Greek for outside of. So an exoplanet is a planet that's outside of our solar system, right? So it's a planet that's rotating around a different star, not the sun.
Okay.
And at this point, we've found about 5,000 of them, and there's probably way more than that, but we found a lot, yeah. So now almost none of them, basically none of them look like Earth, but we found a ton of them that look like Jupiter, a lot that look like Neptune and Uranus. We've found a whole bunch that look nothing like anything we have in our solar system. But basically, exoplanets is just planets outside of our solar system.
Okay. Thank you. That actually makes a lot more sense. I thought
Part of the reason why you heard a lot about it when you were young too is that probably right about when you started grade school is when we started finding them. So it would have been in the news.
Okay.
A lot. It was all
Yeah.
brand new. So
Cool. And then my last question for you on my list, and then I'll let Tucker ask his last ones was, so why do some planets either in our solar system or out of our solar system, how come some of them have like more moons than others? Is it like because they have a greater force of gravity that keeps them in there versus like others
yes,
like us? Okay.
it's a mix of a couple things. It's for starters, yes. If you have more gravity, you're gonna have more moons. For for two reasons. One, when you're forming, if not everything stuck to you, but some stuff was nearby left behind, it might get in orbit. Two, when you're bigger, when other random things are flying around, because there's a point when the solar system's forming, the big planets sort of they condense out of the gas, they solidify. You get these nice big planets. You get the little terrestrial planets like Earth, but there's still lots of junk flying around. It's a crazy, chaotic time. There's a reason why life didn't exist back then because the surfaces of many of these planets were constantly being bombarded.
Mhm.
If you're one of the big guys, two things can happen. You can capture the all these small objects that didn't quite hit you but got close. So you have enough gravity you capture them. Or you do get hit, but you're so big it doesn't destroy you. But the thing that hits you sort of gets broken up and can end up in orbit around you. So that's one reason. But you can, as I'm telling this story, you might imagine part of this is also luck, just dumb luck, right? Because you can't guarantee, like Earth has a fairly large moon for the size of the planet. It's not, we know how it happened, but like when we run our simulations to try to recreate it, you don't get it every time. Like you only get it a subset of time. So it's a little bit of luck as well.
Okay.
So, luck is always at play.
Okay. Thank you.
Yeah.
All right. So my final question would be, do the orbital dynamics of different exoplanets like vary, and like why do they vary?
Usually the variations of planets has a lot to do with what happened early on during when they formed, right?
Okay.
And what causes so most of the time over if you let enough time pass, no matter how a planet forms, it tends to the orbit becomes circular eventually, unless there are other things floating around nearby causing trouble. For example, in our solar system, Jupiter is so big that even though we're all orbiting the sun, Jupiter has a large effect on what kind of shape and patterns our orbits have, right? And actually, Jupiter can take planets and tilt them around too, because Jupiter's has that much gravity, it can and do things. So there are some weird exotic exoplanet systems where their own equivalent of a Jupiter is doing weird things, and so you have planets that are a little bit more eccentric orbits than, say, Earth. Also, there are planets around binary stars, and now that gets complicated because now you have two stars which are super heavy and dense and have a lot of gravity. They're tugging at you, they're competing for your attention. And then maybe there's also a gas giant floating around nearby, and you're just this little terrestrial planet. You're going to have a very weird orbit because of that. So a lot of it comes down to what happened during formation and who formed nearby you that sets the kind of orbit you have. But ultimately, the longer that things go on, unless you get locked into a position, most planets are trying to circularize. And there's a whole class of planets that are what are called tidally locked. They not only have circular orbits, but they've at some point, because of the tug of the sun on the planet, and if the planet is not evenly distributed in mass, like it has a little bit of mass on one side, not the other, eventually that tugging lines it up so the planet no longer, like, Earth rotates 24 hours, every 24 hours we rotate, but we take 365 days a year to get around the sun. If we became tidally locked, our rotation rate, our day would be 365 years. Sorry, 365 days. Like it would take one whole rotation to just rotate once. And that's what's called tidally locked. And there's a whole bunch of planets that are like that. And there is an object very close to us that is also like that, which is the moon. The moon happens to be tidally locked. That's why we always talk about the near side and the far side, because you can never see the far side of the moon, because the moon's always showing the same face to us. And we used to think that only happened to satellites, but now we've discovered exoplanets that are like that as well.
Oh, very cool.
Well, that wraps up all of my questions, and I'm pretty sure all of Tucker's questions as well. So just wanted to say thank you for taking the time to have this short little interview, expand our knowledge a little bit on the whole, like, I know the solar system and like space is just so unknown. So it's cool to just get a little bit
It's
better.
fun.
Yeah, no, it is really cool. So thank you so
Okay.
much and have a great rest of your day. And hopefully it's not too busy.
No, well, it always is, but I like that. All right, well, you guys have a good time.